You and a friend live on neighboring farms. You both love your pet cows very much. Each cow is tethered to a pole by 100-foot-long ropes, so they don't wander off. The two poles are 100 feet apart. Find the area of grass where they can both graze together. So your cow is tethered to this pole and your friend's cow is tethered to this pole. 100 is the length of the rope. So your cow can graze in this whole area, and your friend's cow can graze in this whole area. Now, I actually gave you the area of this at the end of one of our lessons, and I'll link it at the end of this video and underneath the video. I gave you the answer to this problem, and I said this is a challenge problem if you wanted to work it out. And this question here, you already had a formula for it that you had access to. So you definitely could have looked into it. The picture, in fact, I cropped from exactly that lesson. Let's do some thinking. My rope is 100 feet long for my cow. This is 100. This is also 100. Sorry, the drawings are not scaled the same way. These are all 100. But so is that line. What do we have once again? We have another two equilateral triangles. I saw a question similar to this, and I don't even know if it was exactly the same, and I even cut things out and layered them on top of each other to kind of show you how the areas all worked out. Now I want to know this area where both cows can graze. If I found the area of a sector, it would not include that segment or that segment. So I'd have to really find the area of the sector twice. But by doing that, I overcounted these two triangles, one each. So I'll do sector plus sector. Now I have four triangles, now I only need two. Minus triangle, or minus rhombus. Whatever way you prefer. So, sector. Since they're equilaterals, I'm going to use this 120 degrees as my central angle. 120 out of 360 is what fraction of a whole circle? It's 1/3. Pi r squared. 1/3, 100 squared. So area of one of the sectors is 10,000 pi over 3. That's one sector. 2 sectors is 20,000 pi over 3. Now I need to subtract out 2 of these triangles. On a previous example, we even found the area of an equilateral triangle of side length x. What was that area? So I used the over and over again equilateral triangle, so there's really less work for you. How long is x in this situation? X is actually 100. 100 squared we just saw, and that's 10,000. Area of the 2 sectors, that's area of 1 triangle. What's the area of 2 triangles? All you need to do is the 2 sectors minus 2 triangles. And I'll get my answer. Just going to slide this up so I could do it over here. I'm going to reduce this fraction. 4 goes into 20. There's your answer. If you found a common denominator, that common denominator would be 3. You wouldn't have to make it 12. So I could leave the answer like this, or times 3 on top and bottom, all over 3. Or I could factor out the greatest common factor. Looks like our greatest common factor could be, depending how you look at it, I could take out 5,000, or I could take out 5,000 over 3. That would be 4 pi. That would be 3 square root 3. One answer, 3 ways.